Hi everyone. So this is investigation number 14, which is on page 191. I've gone over this many times. I think that I have it down to be able to explain this clearly and concisely. So let's see how things go. All right, so investigation number 14, it says plot the fire stations A and B on coordinate axes either by hand or using a software package. And if you're using a software package, GeoGebra is a really good one. And if we were in class, we would definitely go over how to do that. But here we are. We're not, so let's go by hand. And I actually think it's easier to do it by hand first and then be able to apply this to a graphing package. At least I think you have a better understanding of what's going on, a deeper understanding. All right, so the first thing we need to do are plot points A, which is at 1, 4. So 1, 2, 3, 4. There we go, point A. And then point B is at 1, 0. Okay, so the first question is, and I think we have fire stations. So we have fire station. Where is the perpendicular bisector? The perpendicular bisector is going to be halfway in between. This is a distance of 4, and so halfway is right there. And in fact, that's y equals 2. Okay, so now this should be obvious that if you live in this section of town and your house catches on fire, then this is a fire station that should respond. And if you live on this side of town, then the fire station that should respond to your emergency is B. There we go. All right, so far so good. So that's part 1. Part 2, draw the perpendicular bisector of AB and gently shade those points nearest to A. So that's shade, 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 shade. How would you divide the township into 2 regions of fire station C is not yet in operation? Okay, well, that's what I just talked about, A or B, depending on which side you live on. Okay, so now add fire station C to the diagram. Okay, so C is at 4, 3. So we go 1, 2, 3, 4, and 1, 2, 3. So here is fire station C. Okay, so let's pretend that B was not here for a moment, and it was just fire station A or C that we were deciding between. So, clearly I'm doing this by hand. I'm going to pick, so let's see, so there's kind of my segment. My midpoint is about there-ish, and I'm going to draw this in like so. Okay, so that's my rough, this would be my segment, this is my rough perpendicular bisector. And if I live on this side of my perpendicular bisector, I'm going to go to this fire station or this fire station on this side of the line. Okay, so far so good. Okay, and of course if we cover up, let's cover up A for a moment and say that we are going to go between, B or C is our choices here for fire departments. So again, it's kind of like 1, 2, 3, so right about there. And I'm going to draw a bisector here. There we go. Okay, so let's review about, I'll just say this. So again, if you're on B, then if you're in this section of town, you go to B. If you're in this section of town, you go to C. Okay. And any point that's on this bisector here is equidistant from B or from C. Any point along here. And then if I'm just off of it, then I'm closer to C. If I'm off of this, I'm closer to B. Likewise here, all these points are equidistant from A and C. If your house is right there, then either one of these fire departments can respond. If you're just a little bit over here, then A should respond. Similarly, so here, no matter where you are on this perpendicular bisector of AB, either one of these, if you're right there, you're equidistant from A or from B. And if you're just a little bit over here, then you're A. Now, of course, C is right there. Okay, so anywhere along here is equidistant from A and B. Anywhere along here is equidistant from B and C. Anywhere along here is equidistant from A and C. So right there, where it overlaps, or all 3 perpendicular bisectors overlap, that means that that point is equidistant from A, B, or C. So if your house is right there, then it doesn't matter which fire department responds to you. So that might be a good place to live. All right, and that place, that's called a vertex. All right, and this would be, I don't have these colored in yet, but then we have a cell and a cell and a cell. Those are cell boundaries, and where they come together is a vertex. Okay, and the boundaries are called the cells. The boundaries are made up of our perpendicular bisectors. So now I could actually, I could extend this out a little bit. So let's do this. I actually don't need that little part there, and I can't erase it because I did so in pen. Anyhow, so if you live anywhere around here, you should be in C. If you live anywhere in this section, you should be going, the B fire department should be getting to you. And if you're up in here, I can use a different color here. I can use blue for this one. If you're up in here, then A should be coming after you. All right, does that make sense? So there's 3. Now, skipping ahead to part 6 here, it says, or question 6, it says, what is the incremental logarithm? So what we just did was an incremental logarithm. We added A and B, then we added in C. And now what we're going to do is we're going to add in D. So we're going to add in D here, and of course I've got this all messed up here. So let's just do this a little bit differently. Let's do this. And I'm still going to do this. Whoops, that's kind of bad, but it's okay. We'll survive. All right, I'll do this. And then it's at, I've done this so many times, I don't need to look at this anymore. It's at 1, 0, 2, 3, 1, 2, 3, 4. Thank you. And then we've got another one at 4, 3. So 1, 2, 3, 4, 1, 2, 3. And then D is our new one, 1, 2, 3, 4, 5, and 1. Okay, so this time I'm going to go through things a little bit faster like. And, it's perfectly fine to do this. I'm going to have now normally I would draw a segment here, right? And then draw my perpendicular bisector, so figure out where halfway is, but I'm just going to eyeball it. There we go. I'm going to say that halfway is about there. And then I'm going to say, well, this one's an easy one. Halfway is about there. And then segment here, halfway is about there. And then I'm going to draw these lines so that they meet. So it's going to be like this. And if I was, this just saves me erasing or, okay, there we go. So now if I could have drawn, I'll just extend this. The last one I did in pen. So this is really this one, right? Just without, that's it, just bare bones. This is what we actually need. And so if we label this A, B, C, then again, here's A, B, and then C is about to be defined. Okay, so what about between C and D? Well, again, the perpendicular, just pretend that all these are gone. So then the perpendicular bisector is going to be the bisector of this segment. So it's going to look something like that. There we go. And then if you live on this side of town, C fire department. If you live on this side, D fire department, right? Okay, now we can do the same thing with B and D. Let's pretend that these do not exist, and then we draw a perpendicular bisector here. So I'm estimating this. So between B and D, and I'm going to say it's about, there. And then I'm going to draw this perpendicular like, okay. And then I'm going to extend this. There we go. So this is kind of like, again, doing this freehand, you're going to be a little bit off. So imagine this is my perpendicular bisector, again here. So if we ignore all this, this is the perpendicular bisector, so this half, depending on where you are. And then if you notice, and then this point here is where our 3 perpendicular bisectors meet, right? This one, and then this one is between B and C. Just like this was I had 3 come together here. And so now what do I have? Now I have 4 sections. I have 4 cells, 1 cell, 2 cell, 3 cell, 4 cell. If I live here, fire department B, here A, here C, here D. Woo! Okay, is that better? Hopefully that's clear now. A couple of the other questions here. Let's see. The township is relocating Fire Station D within its territory. Okay, that's the one that we just did. Why does adding the fire stations one by one make sense for creating a town map? Well, because then you know where really the division line is about populations, right? So that's one of the reasons why we would want to do that, is we want to find out, well, where are people settling in the first place? Okay, that's it. Hope that is clear. I hope you feel good about Voronoi diagrams now. And the next assignment hopefully should be that much easier. If you have any questions, please let me know.